What are the basics of motion control tuning? What exactly happens when you implement a PD controller? In this short video I will show you that a PD controller is in fact creating a servo spring and a servo damper to your mechanical system. So creating an electronic spring and damper. And I'm going to show it to you by using this block diagram. And in this block diagram, this is my process, which is a single mass. And the transfer function is 1 over ms squared. And the transfer function is related to Newton's law, which says that F equals m times a, in which a is the acceleration. So F equals m times the double derivative of the output, the position y in this case. So if F equals m times the double derivative of the output y, then in the S domain, F equals m times s squared times the output y, the position. So y over F is 1 over ms squared. So this is my process, my single mass process, and I'm going to control this process by a PD controller, a standard PD controller with a proportional part which has gain Kp in this example and a derivative part which has the gain Kd. And in this process, in this feedback process in which R is the reference, a disturbance is at the input of my process. And now I'm going to derive the relationship between that output y and the disturbance force over here, F dis. And I put the reference to 0. And then I can say, well, from F to y, the forward path is my process. And in the loop, I see the process times the controller. So there we go. The transfer function y over F disturbance equals 1 over ms squared divided by 1 plus the controller Kp plus Kd times S times 1 over ms squared. And when you multiply the numerator and denominator with ms squared, you get the transfer function y over F disturbance equals 1 over ms squared plus Kd times S plus Kp. So Kd is the derivative part of the controller, Kp is the proportional part of the controller. And I'm going to show you that Kp is nothing more than a servo spring and Kd acts like a servo damper. And why is that? Because have a quick look to this mechanical system. And in this mechanical system, I have a mass m, and the mass m is connected through a spring and a damper to the frame. And we are going to show and derive the relationship between the output y, the position of the mass, as a function of the input force F. And I can derive an equation of motion which says that F minus the spring force minus the damping force equals m times the derivative of y, m times a. So F minus c times y, which is the spring force, minus d times the derivative of the position, which is the speed, equals m times the double derivative of y, which is the acceleration. Or we can say F equals m times the double derivative of the position, which is shown over here. This means the double derivative, so it's m times a, the double derivative of y, plus the damping force d times the speed, which is d times the derivative of the position, plus c times y over here. And now we can derive the transfer function y over f in the S domain. So we're going to replace the derivative by s. And then we get in the Laplace domain f equals m times s squared times y plus d times s times y plus c times y. So y over f in the S domain, in the Laplace domain, is equal to 1 over ms squared plus d times s plus c. And now see the analogy between the Kp over here, the proportional part of my controller, and my spring, and my Kd over here, the derivative part of the controller, and my damper here. So what I've realized by having a proportional derivative controller, PD controller, acting on a single mass system, that I created, in fact, an electronic spring and an electronic damper, because I have a relationship to this system. And you can feel that in practice. For instance, when you make this controller and you set that set point to 0, please turn the motor shaft by hand and you feel that servo spring, which is caused by that Kp. And when you increase that Kp, you feel a stronger spring. And you can also feel the damper when you manually turn that motor shaft quickly and in a slow transition. And then you feel the damping force really acting on your hand. So in fact, we have created a servo spring and a servo damping. And that's why we define a PD controller for a motion control system. That's it. Thank you for watching.